You know, our planet is wrapped in this blanket of air we call the atmosphere. But here's the thing, that blanket isn't solid. It's actually filled with these invisible gateways, these secret windows that are absolutely crucial for science, for technology, and, yeah, for life itself. So let's dive in and explore what these windows are and why our world really depends on them.
So let's just start with that simple question. What if our atmosphere had windows? Now, I'm not talking about, glass panes floating up in the sky. I mean specific transparent gaps that let certain things pass right through while blocking others. Well, the truth is, it does. Our atmosphere is full of them, and as it turns out, we depend on them for our very existence.
And these windows, they're not just some cute metaphor. Nope, they are a very real scientific phenomenon. They're the invisible channels that connect us to the energy of the sun and the incredible vastness of space.
Okay, so here's the technical definition. An atmospheric window is basically any part of the electromagnetic spectrum, and that includes things like visible light, radio waves, infrared heat, that can punch all the way through our atmosphere and reach the ground without getting soaked up by all the gases in the air.
Here's an easy way to think about it. The sun is just blasting us with a whole spectrum of energy, right? Well, our atmosphere acts like this super complex filter blocking some of that energy. These windows we're talking about, they're the gaps in that filter, and they're perfectly calibrated to let in the light and the warmth that fuels our entire planet, while also letting excess heat escape back out into space. It's a beautiful system.
And the amount of energy that gets through is just staggering. Through these windows, about 200 watts of solar power hit every single square meter of the Earth's surface. That is the energy that powers our climate, that sustains all life. And let's be clear, without these windows, our planet would just be a frozen, totally uninhabitable rock.
So, if the atmosphere is a filter, what's it made of? I mean, what tiny little particles are actually doing all this work? All the blocking and filtering that creates these essential windows for us? Well, the answer is molecules. It comes down to countless individual molecules floating around in the air, especially greenhouse gases like water vapor and CO2. They act like these tiny little gatekeepers. See, each type of molecule is tuned to absorb very specific wavelengths of energy, which creates an invisible wall that those specific energy waves just can't get through.
Okay, but that raises a huge question, right? You've got this chaotic mix of all these different gases, and each one is absorbing different little bits of the spectrum. So how on earth can scientists create a precise map of all these windows and walls? How do they actually know what gets through? Well, they do it with something called HITRAN. And you can think of this as the master rule book for our atmosphere. It represents this monumental scientific effort to document every single interaction between light and the molecules in our air. So what is HITRAN really? It's a massive database that exhaustively, and I mean exhaustively, details how 54 different types of molecules interact with light. For every single one, it tells scientists exactly which wavelengths it's going to absorb and how strongly it'll absorb them. This is the bedrock data that allows us to map those atmospheric windows with incredible precision.
Let's go back to our house analogy for a second. If the atmosphere is the building itself, then HITRAN is the complete architectural blueprint. It doesn't just say, hey, there are windows over here. No. It shows their exact size, their precise location, and the exact type of light that can shine through each and every one.
And just to give you a sense of how important this is, as of 2021, over 20,700 registered scientific users rely on this single database for their work. It is the invisible cornerstone that supports everything from climate science all the way to space exploration.
All right, to really see why all this matters, let's zoom in on one super crucial molecule and a pretty recent scientific challenge, solving the water vapor puzzle. So why water vapor? Why all the fuss? Well, because it is the single most significant absorber of energy in our entire atmosphere. Its effect is just enormous. So if your data on water vapor is even a tiny bit off, all of your atmospheric models, they're going to be wrong. Getting it perfect is a massive, massive priority.
And that created a huge problem. See, the go-to database, the 2016 version of HITRAN, had some known flaws in its water vapor data. The models that were built on it just didn't line up with what we were seeing in the real world. So a massive update was launched with this super ambitious goal: achieve sub% accuracy. We're talking a level of precision demanded by brand new missions like the Tempo Pollution Satellite and, of course, the James Webb Space Telescope.
And here, right here,
is the visual proof of that problem. That solid black line, that's the real observed data from our atmosphere. Now look at the yellow dashed line. That's the prediction made using the old 2016 database. And down in the bottom panel, you can see all those big error spikes. The model was just fundamentally out of sync with reality.
Okay, now look at this. This is the payoff. The green line is the new model, the one using the updated HitTran 2020 data. It is lying almost perfectly on top of that black line of real-world data. And look at the errors in the bottom panel. They've just flattened out. It is a night and day difference, and it was all achieved through these painstaking, incredibly detailed updates to the data.
So all this work kind of begs the question, right? Why does this obsessive level of detail even matter? What does getting this incredible accuracy actually, well, unlock for us?
Let's actually put some numbers on that improvement. This chart here shows the model's error rate. The update pushed that error down from 0.965 to 0.888. Now, I know those numbers might look pretty small, but for the scientists trying to understand our planet, that reduction represents a massive leap forward in precision.
And this is what that precision unlocks. It means our climate models become way more reliable. It lets satellites like Tempo track pollution with pinpoint accuracy. It's the key that allows the James Webb Space Telescope to analyze the faint little sliver of light passing through the atmosphere of a planet hundreds of light years away. And it even has applications in medicine, helping to analyze the chemical markers in our own breath. It's amazing stuff.
You know, this quote from the scientists behind the update really just says it all. Basically, any mission that looks at light to understand an atmosphere, doesn't matter if it's our own or another planet's, is built on the foundation of HitTran data, period. And it all comes back to this one simple idea. To understand the big picture, you absolutely have to master the smallest details. We've just seen how a database of molecules lets us study planets light years away. It really leaves you wondering, what other hidden rule books are out there just waiting for us to read them that will unlock the next great secrets of our universe?